Bismillahirrahmanirrahim. Dear students, Assalamu alaikum and welcome to e-learning Al Noor International School Grade 12 Chemistry course. I'm your chemistry teacher Faraz Anjum. Okay student, in this week we will continue chapter 24, the chemistry of life, lesson 24.5 nucleic acid, and we will cover the textbook pages 858 till 861. So please open your textbook page number 858. Okay, in this week, our main objective of this lesson are explain the gene mutation and identify two examples of DNA technology used today. So I start with the gene mutation first. What are gene mutation? Okay, students. Now, when a change occurs in a DNA code word, the result in a mutation in the DNA. So means substitution, addition, or deletion of one or more nucleotides such as guanine, cytosine, adenine, thymine in a DNA molecule are called gene mutation. So the effect of the deletion of a single base from the gene can be illustrated by the following analogy. You can see here, suppose a string of letter of the alphabet goes as follow: P A T T H E R E D C A T. In this, you can see the letters may not be like the same at first glance. However, if you separate them into three-letter words, they form a perfectly sensible statement like this: PAT, 1, THE, the, RED, red, CAT, cat. So, pat, the red cat. But here you can't analyze what is it. Pat, okay, but PATTHED, okay. But when you separate out, you can sense now. What is it? Pat, the red cat. So means you're going to pet the red cat. So it makes the sense. After that, you can see here, suppose the string letter of the alphabet goes follow. Now delete the first letter P. Delete the first letter P. And again separate in the string into three-letter segment. So how it going to be after deleting P? Okay. So start from here. ATT. So ATT, HER, and EDC, and late one or our last one will be AT, not a third one now. So, and remember why we are doing? Remember the codon must be 3 nucleotide, okay, 3 letter. So ATT, HER, and doesn't blah blah blah. Okay, so it not make the sense. What is it? Nonsensical. So this sequence is nonsensical. Similarly, the deletion of the base in the DNA base sequence can turn the information into the nonsense. Okay, such as you are going to make the particular protein or amino acid or peptides. After deleting, addition, or substitution, it changed. I'm just giving the example, then you can understand easily. You are going to prepare the tea. Instead of putting sugar, you're going to put the salt. So tea will be how? You can see. Okay, so deletion, addition, or substitution can change the whole product. Same thing, another example. Suppose you are going to prepare any food like a pizza. In the pizza, instead of putting cheese, you are putting milk. Is it feasible? No. So same thing here, that if you change a recipe or code, the DNA molecule going to be nonsense. Such mutation might result in a production of the faulty protein or of no protein at all. So diseases that result from gene mutation are called genetic disorders. Thousands of genetic disorders have been identified. Yes, friend. Now let's take the example of galactosemia. Galactosemia is an example of the genetic disorder that affects about 1 in 55,000 newborn babies. Galactosemia results from a mutation in an enzyme called GALT, G-A-L-T, which is galactose 1-phosphate uridyl transferase. GALT needs to break down the sugar galactose into glucose. So breaking the sugar from galactose to glucose. Now without normal galactose cannot be built up in the body, cause the kidney failure and enlarged liver or cataracts and brain damage. Cataract basically is an eye disease in which the lens is going to be blurred. So a person with the galactosemia cannot complete the breakdown of lactose. The only treatment is to avoid the food containing lactose like dairy and dried beans. Okay, here is showing something. See, this is the lactose. Lactose is breaking down in glucose and galactose. Okay, this lactose, milk. Okay, when you drink the milk or have the milk, baby have the milk, okay, in the form of lactose. Lactose going to break down into galactose and glucose. Okay, and glucose going to use the energy, and galactose, okay, here if it's normal, this is galt, okay, which is enzyme, it attached here and give you the simple glucose. It convert the galactose into the glucose, this enzyme. If it's not there, it cannot be, okay, and because of this glucose we can get the energy. Okay, now if there is no enzyme GLAT, so what going to happen? Galactose remain like this, and then this form of galactose called create the disease called galactosemia. Without a normal GLAT enzyme, galactose and related compound build up a toxic level, and this toxic level going to damage the kidneys, eyes, and liver enlargement, etc. Not all gene mutations are harmful. Occasionally, a mutation can result in the synthesis of protein that is more efficient than the version that previously exists. Such a mutation could thus be beneficial to the survival of the affected organism. Using the sequence, Pat the rat cat has the unmuted sequence that mutation have occurred in the following sequence. You can see this here. First, this is the 80 her EDC, Pat this one, and then this one. So here, what is it? Deletion of the P. Here, substitution of the E. Here, addition of the S. So all are mutation. What are the two examples of DNA technology used today? DNA typing. Number one, the sequence that are similar for members of the same family but are slightly different for almost every individual. Identical twins look similar because they have identical DNA. So DNA typing uses the variation in the DNA individual as a basis of the creating DNA profile to identify a person from sample of his or her hair, skin cell, or the body fluid. Okay, and this is our, because DNA sequence
blueprint,
like a fingerprint means everything are unique, all the details we have. Remember, all the world, all over the world, how many people here in the world, fingerprints totally different. Okay, DNA types have been called DNA fingerprinting. So this is the DNA typing, basically our DNA fingerprinting. Okay, student. Now this DNA typing, to construct our DNA profile, scientists first isolate the DNA in the sample. Only a tiny sample is needed. A sample can be anything that contains the DNA, including teeth, fingernail, blood, hair, saliva, and the skin cell. Normally, for dead bodies who cannot be identified, doctors use this one. Sample can be typed in the several different ways, but the method used for most commonly is short tandem repeat, STR. What is it? Short tandem repeat analysis. Okay, a short tandem repeat is a short segment of DNA that is repeated several times. For example, one region of DNA used by the FBI contains repeat of the sequence AG80. AG80. So DNA profile can be compared with the sample DNA from a non-individual. So this is suppose crime scene sample. Okay. Now this is the suspect one and this one is suspect two. So which one is among them? Who's closest? This is crime scene like anything like a blood or hair fall. So it analyzed this peak created 9 and 10 is peak up. And they caught the suspect one give this DNA mapping and this one suspect two. So which one is closest? Two. The FBI has technology system called combined DNA index system. What is it? Okay, so combined DNA index system. CO means combined. That allows the laboratories throughout the country to share and search the DNA profile. The chance of the two people, except of the identical twins, have the same DNA profile for these 13 regions is 1 in the 1 billion. Now, second technology is recombinant DNA technology. Recombinant DNA technology consists of the method of for cleaving a DNA chain, inserting a new piece of the DNA into a gap created by a cleavage, and releasing the chain. The altered DNA formed by this method is known as recombinant DNA. Now, student, here is a experiment of recombinant DNA technology. In this experiment, DNA from one organism is inserted into the DNA of a different organism. Suppose here what we are going to do, we are going to take a part of DNA or gene from the human being and going to insert into the bacterial cell. So how it going to be? Look here. So human genes clipped out of an enzyme by an enzyme. Now, after taking this gene, we clip here for this genetic code and for this genetic code going to be matched. Okay, and going to fix with the plasmid of bacteria. What is plasmid? Simple circular DNA of bacteria. This is called plasmid. So remove the plasmid, put the human genes in this, attach with this plasmid. After attaching the DNA with the human gene, circular structure called recombinant DNA. Now this recombinant DNA going to insert into the bacterial cell. This technology called recombination of DNA or DNA recombinant technology. Okay, the application of recombinant DNA. Application in medicine, the first practical application of recombinant DNA technology was to insert the gene for making human insulin into bacteria. Insufficient insulin production result the diabetes. You know this one. Okay, so if we don't have the insulin level good in the blood, so sugar level going to be raised. The symptom of the diabetes can be often by controlled by insulin injection. So if we don't produce good amount of insulin, we have to take artificially by the injection. Okay, so now in past, human insulin was not available for this purpose. Pig insulin we used, which quite similar as the use of the substitute. Remember, in past when human recombinant DNA insulin was not available in the market, so normally we use the pig insulin, which is quite dangerous for the health of human. But nowadays, diabetic patients use for the human form of insulin produced by the bacteria that have been altered by the recombinant DNA technology, which we discussed previous slide. Now, other proteins produced by the recombinant technology are used for the medical drugs, such as an enzyme called tissue plasminogen activator (TPA) is used to dissolve blood clot in patients who have suffered heart attack, as well as interferon. Interferon is a protein that give you the immune system high or boost the immune system, is though to relieve or delay some of the debilitating means the patient who going to be weak after the disease effects of the multiple sclerosis basically a condition in which the hard end of the body tissue become very stiff and hard. Okay, because of this we feel the weakness, the patient feel the weakness. So interferon basically give you the boost or immune system high to cope up this. Recombinant DNA technology is also being applied to cure the genetic disorder in an experimental treatment known as gene therapy. Okay, so in gene therapy we can cure the genetic disorders. Now, in agriculture, in agriculture application, new recombinant DNA technology can make the plant resistant to pest and weed killer and produce the fruit and vegetable that are better suited for shipping and storage. The most common trait is in genetically modified crop are herbicides resistance and insect resistance in corn, cotton, soybean, and canola. Crop have been also been genetically modified by pharmaceutical purpose. These so-called pharma crop are genetically modified to produce drug to treat or prevent disease such as cancer or AIDS. Now, genetically altered organisms have many potential benefits, but some people have concern about their safety. There is also concern that genetically modified crop could contaminate other crop if they are grown and processed in closely proximity of them. Now, the most common, this cloning as well. Ethical concerns were raised in 1997 when Scottish scientists announced the birth of a lamb named Dolly. In normal animal reproduction, an offspring is a genetic mixture of the characteristic of both parents. Dolly was a clone. So what is clone? An offspring of a single individual only. Cloning. Polly and Dolly had no fathers. Okay, what is it? Polly and Dolly had no fathers. So Dolly was a female domestic sheep, remarkable for being the first mammal to be cloned from an adult cell. And Polly and her sister Molly were the first mammals to have been successfully cloned from an adult cell and to be genetically modified at the same time. So the birth of cloned animal has raised the question of whether human might eventually be cloned. So many people are concerned about some of the possible outcome of the cloning identical individual. These situations are one aspect of the more general concern about the uniqueness of life. So that's why it's unethical at the moment, it's banned. Which of the following is not an example of DNA technology? Perfect, blood typing. Thank you, student. This is the end of your lesson 24.5, and please write the question in your comment day 1 or day 2 discussion. I can answer you. And please try to solve yourself section assessment 24.5 and workbook of this lesson 24.5. Thank you so much. See you next week.